All right, so we've got the situation where there's bicycle club, and we've got one member's graph of how she traveled, and we're going to use both the graph and we can use the table as well to answer some questions. So if you like, you can pause it to go over those questions. Now, we've got two variables here, distance and time. And so time would be independent. So when we write our sentence, we should write distance as a function of time. And we will also label the axis appropriately. So time in hours. And then distance. Now we're going to list it as distance from the starting point, or distance from the start. And it's in miles. Next question says, during which interval is she moving the fastest? Explain it in terms of the graph. Fastest would be the highest slope, and that's from 0 to 2. You can say it's the steepest, or you could go ahead and do the calculations on slope and compare those values, and it'll be the greatest. Not important whether you have less thans here or less than or equal to, it doesn't matter. Describe what's happening during those first 2 hours. Well, during the first 2 hours, she's traveling at a constant rate of 15 miles per hour because our rise is 30, run is 2. Divide that, you get 15 miles per hour. It's a constant rate because it's a line segment. Anytime it's a straight line or a line segment, it'll be a constant rate. We see 3 distinct line segments here for this function. We want to come up with an equation for each part. Well, that first part, your rise is 30, your run is 2, so your slope is 15, and your y-intercept is 0. So that's where the 15t comes from. You could write it out as y equals 15x plus 0, but then we can simplify that to 15x. And then if we write it in terms of d and t, time is your x, your independent variable. Now, the next portion of this graph, next piece, is from 2 to 4, and the final piece will be from 4 to 7. You'll notice for that second piece, it's horizontal. If you wrote it in terms of y's, x's and y's, you'd say y equals 30. This is for the second piece on the graph. All right, and then for this last piece, we need to come up with the slope. The rise 30, run 3. And so our slope is 30 over 3, or 10. And then we go through the point for 30. So we can use point slope. And I'll just agree to use the leftmost point, but technically you could use any point on there. So if we use the leftmost point, we got 430. That'll be the x sub 1, y sub 1. We'll substitute into point slope. Now once you've substituted in, you have y minus 30 equals 10 times, in parentheses, x minus 4. We're not worried about the parentheses, but we do need the y to be by itself because in our equation we have d equals. And so we'll add 30 to each side of this. And so we'll have y equals 10 times, in parentheses, x minus 4 plus 30. And then we can rewrite it in terms of d and t. d equals 10 times, in parentheses, t minus 4 plus 30. And of course our last segment last piece is from 4 to 7. So if you see where it crosses the y-axis, you can use slope-intercept. If it's horizontal, it's just going to be a number, just like y equal to a number is horizontal line. And then if it's away from the origin, you don't see that that y-intercept, you can use point slope and then get the y by itself. Alright, here, when is D 22? So look at your graph and locate when the distance is 22. And then think about what piece or what equation you should use. We're on that first piece, so we should use D equals 15 times T. We'll substitute in. The distance is 22. Let's solve that for T. Divide both sides by 15 to get rid of the multiplication by 15. And so we get 22 over 15, or 1 7/15. And that's hours. Typically when we break hours down, we don't use 15ths. So let's change that to something that's more useful. Typically we break hours into minutes. And so if we change this to 60 parts, then we can figure out how many minutes it is. So if you multiply the top and the bottom by 4, you get to a denominator of 60. So 28/60ths of an hour is the same as 28 minutes. So we can say 1 hour, 28 minutes is our time there when the distance is 22. All right, here we want to find the average speed from 1 to 3 hours. So locate your 2 points, and then you're going to substitute it into the slope formula. So on top we'll have 30 minus 15, on the bottom 3 minus 2, and so we get 15 divided by 2, or 7.5 miles per hour. So the average speed from 1 to 3 hours is 7.5 miles per hour. Think about the first piece was 15, second piece was 0, average those together, and you get 7.5. Number 8, suppose at the end of the 4th hour, the bicyclist decides to go back to her starting position. Illustrate what that might look like on the graph. So you can do a sketch, you don't have a second graph, or you can write on top of the original graph, just knowing that the pencil part is your answer to number 8. All right, so some people did something like this. They went back to the origin. But if you do that, then you're traveling back in time. And although Uncle Rico and Napoleon Dynamite really would like to go back in time, it's not widely available yet, so we can't do that. So we'll take that off. Some people went to the point 40. Well, what's the issue with that? You're changing where you are, the distance, location, and no time is changing. So I know if you're a Star Trek fan, you think that that you can teleport, but it's still not widely available yet, so we can't do that. All right, so most people came up with either maybe going to 70, that would have the same speed as that original line segment that went from, 430 to 760. So that would be fine. They did not tell us the speed. So if you went to 60, which would match the speed on that first segment, that would be fine. Some people accelerated to 50, that would be fine as well. Your time has to increase, your distance is going to go to 0. So you've got some flexibility there. And if you'd like, you can do number 9.